CRD 3.1, Common Factors in Polynomials. So in this chapter, we're going to learn how to undo multiplication. So you know when you FOIL two polynomials, well, if you're going to undo multiplication, sometimes it's called division, yes, and division is related, but it's also called factoring, just like you did those prime factorization trees back in Jousting Armadillos. So let's remember, what is a factor? Well, I have what is a factor of 10x, but let's first start with even easier. What is a factor of 10? All right, well, the factors of 10 are numbers that evenly go into 10. The factors of 10 are 1, 2, 5, and 10. All of those numbers go evenly into 10. So what is a factor of 10x? Well, it is all of these things right here. 1, 2, 5, 10. But what am I going to multiply 1 by to get 10x? Well, I'm going to multiply 1 by 10x. So that's a factor as well. What am I going to multiply 2 by to get 10x? 5x, that's also a factor. 5 and 2x, those are factor pairs. And then 10 times x. So now I've listed all of the factors of 10x. If it was 10x squared, I would have an even longer list because I'd have to have an x and an x squared and those kinds of things, but we'll get to that. So if I look at two polynomials or two monomials, I have 12x and 16. What is a common factor? Well, if I think of all the factors of 12, I could even do a prime factorization tree if I wanted to. But I think in this case, it's going to be a little bit easier to just list it out. So the factors of 12x, and actually equals is not a good idea. The factors of 12x are 1, 2, 3, 4, 6, excuse me, 12, right? And then what would I multiply 12 to get 12x? So just x. What would I multiply 6? 2x, 3x, 4x, 6x, and 12x. Those are all of my common factor. No, excuse me. Those are all my factors of 12x. Well, 16 is going to be a little bit easier because it doesn't have an x. It's going to be 1, 2, 3 doesn't go in, 4 goes in, 5 doesn't go in, 6 doesn't go in, 7 doesn't go in, 8 goes in, 9, 10, 16. So a common factor would be 1 is a common factor, 2 is a common factor, 3 is not, 4 is a common factor, 6, 8, 12, 16. Okay, so that's it. So then if I ask myself, well, what's the greatest common factor? Well, that's going to be 4. Okay, hopefully you're going to start to be able to look at this and say, what's the biggest thing that goes into this? The biggest thing that goes into this is 4. Okay, all right, moving along. So this is more the kind of thing we're getting towards. The last page was review. So let's take a look at this. If I distribute this, this is going kind of one direction, meaning you're multiplying. 12 times 6x is 12x. 12 times 5y is 10y. So that's distributing or multiplying. Well, now we're going to do the opposite. We're going to factor out the greatest common factor. So it looks like I crossed that out, I know. So factoring would be the opposite of multiplying or distributing. So what that looks like is I want to take this and I want to undistribute it. Now that's not a math term. The math term is factor. But if I want to undistribute it, I know I'm going to have a number outside the parentheses. I'm going to have parentheses. I'm going to have something plus something else. So the number that goes right here is going to be the greatest common factor, the GCF. So let's look at these. They don't share a variable, so that's not in their factors, but they do share a factor of 1, of 2, and that's it. So 2 is going to be their GCF. What am I going to multiply 2 by to get 12x? Oh yeah, 6x. What am I going to multiply 2 by to get 10y? Oh yeah, 5y. So 2 is on the outside and 6x plus 5y is on the inside. Notice how it's the exact same problem as up here. I multiplied it in, then I kind of sucked it out to the front, or I factored it. All right, we'll try one more where it's right in front of you. Distribute. So I have negative 3x. I'm going to multiply that into the parentheses. So what do I get? I get negative 3x squared plus, because of the negative and negative, 21x. Okay, now I'm going to have negative 3x squared plus 21x. Well, I know the answer here, but still, if I didn't, I'm going to factor out the greatest common factor. Okay, so that means I'm going to put the greatest common factor here. I'm going to have parentheses, and I'm going to have 2 blanks to fill in inside, if it helps you draw this out each time. Okay, so I look at this and I say, what is my greatest common factor? I don't generally want to have a negative term leading off inside my parentheses, so I'd like to pull the negative out, even though 21 doesn't have the negative. So it's probably debatable as to whether it should be negative 3x in the front or whether it should be positive 3x in the front. I could probably accept either answer. But I do know that I do know that 3 goes into both those numbers, and that's the largest number that goes into both of them. This one has x squared, this one has x, so I can't pull an x squared out, but I can take an x out. If I multiply negative 3x times whatever's in the parentheses, all I need is an x, right? Negative 3x times x is negative 3x squared. If I multiply negative 3x times this side of the parentheses, I should get positive 21x. Well, that means that this is going to have to be negative, because that's how I'm going to get a positive, and then I'm going to need a 7 to get my 21. So that's my final answer. Okay, now this says factor a negative 1 out of the following polynomial. Okay, well, I'm telling you what I want you to take out. It doesn't have any other number in common. They don't share any factors except for 1. But you can also pull out a negative 1, and that can be helpful in several situations later in the book. It's really just altering the state of what you have. So if I pulled a negative 1 out, what's going to be remaining? Well, negative 3x squared plus 7x minus 9. Can you see that all it really did was change the signs? Because if I distribute this right back in, I would get negative 1 times negative 3x would be positive 3x squared. Negative 1 times positive 7x would be negative 7x, and negative 1 times negative 9 would be positive 9, which is where I started. It's just kind of a circle through it. Okay, and now this is going to be kind of a funny one. Prime polynomials and partial factoring. So prime polynomials, that happens sometimes. Let's think about what a prime number is. If I have the number 17, that's a prime number, and I try and do a factor tree for 17, all I'm going to get is 1 and 17, right? Because a prime number is a number that only has 1 and itself as factors. Well, this polynomial right here, is this the one I just used? No. But this one right here doesn't have anything in common. It doesn't have any common factors. 6, 3, and 7 don't have any common factors except for 1. X squared, x, and no variable don't have any common variables except for 1. So therefore, if I were to factor this, all it would be is, which that really didn't do anything, right? Pulling a 1 out. I really didn't change anything. I just put a 1 here. It's basically repetitive. So instead of doing that, that's actually not a good choice, really. You can state that this polynomial is prime, meaning all I can come up with is 1 times itself. And that will happen in this chapter. Okay, there's this other thing called partial factoring. If I take 6x squared plus 3x minus 7, I see that these 2 in the front have a common factor, but not the 7. So maybe I just want to factor the first part. So I could pull out a 3x, which would leave me with 2x plus 1, and then I just leave the 7. So I partially factored this polynomial. And again, that can be useful, just like pulling out a negative 1 can be useful. This lesson is not overly challenging, and I believe that with some reading in the lesson, you should be able to get through it. It is step 1 of factoring, and we will be factoring throughout this chapter. Good luck.